Let's look at the concept of limiting reactants. This is the idea that when you have a chemical reaction going on and you put two things together, one of them is going to run out first. One of them is going to limit how much of your products can be produced. So the thing that runs out first is your limiting reactant. Here's an example. In this reaction, hydrogen plus oxygen is combining to make water. So when you balance that, there are two hydrogen molecules plus one oxygen molecule combining to produce two of these water molecules. If you begin this reaction with 4 hydrogen molecules and 4 oxygen molecules, hydrogen runs out first. Notice that we need 2 hydrogen molecules for every 1 oxygen molecule. Hydrogen runs out first. That limits the amount of water that can be produced. The other thing that I notice is that there are 2 unreacted oxygen molecules after the reaction takes place. 2 of these guys didn't get used. So hydrogen was the limiting reactant. Oxygen is the excess reactant. So what I want to show you in this video is how you can recognize a limiting reactant problem, a few steps to help you identify your limiting reactant, and then how to solve the question. Here's an example. How many grams of ammonia can be produced when 10 grams of nitrogen and 10 grams of hydrogen react? So here's my chemical reaction. Nitrogen plus hydrogen are reacting to produce ammonia. The reaction has been balanced. Here is how I know this is a limiting reactant problem. I was given information about 2 of my reactants. I was given information about nitrogen and information about hydrogen. That's my clue that this is a limiting reactant problem. Because how do I know which one of those pieces of information to start with? So there are some steps that you can use to help you identify your limiting reactant. The first thing that you want to do is convert to moles. So I've taken both of the pieces of information that I was given and converted them to moles. 10 grams of nitrogen divided by the molar mass off the periodic table gives me 0.357 moles of nitrogen. 10 grams of hydrogen divided by the molar mass off the periodic table for 2 hydrogen atoms gives me 4.96 moles of hydrogen. So I have converted to moles. The second thing that I want to do is to divide by the coefficients. So for nitrogen, I took that number of moles and divided it by the coefficient for nitrogen. I'm going to do the same thing for hydrogen. Hydrogen, I had 4.96 moles. Divided by the coefficient for hydrogen gives me a number of 1.65. These numbers are pretty much meaningless, except they can help us to identify the limiting reactant. Whichever one is the lowest is your limiting reactant. In this case, I now know that nitrogen is limiting and hydrogen is the excess reactant. I'm not going to use these numbers for anything else other than identifying the limiting reactant. I have not answered this question yet. All I've done is said which one is limiting. Now, step 3, I use the limiting reactant to answer the original question. So my original question was how many grams of ammonia can be produced. I'm going to start with my information about nitrogen because nitrogen was limiting. So at this point, it looks like a normal stoichiometry problem where I'm starting with the limiting reactant. 10 grams of nitrogen, using the molar mass of nitrogen off the periodic table to convert to moles, using a mole ratio between nitrogen and NH3 to convert to NH3, and then using the molar mass for NH3 to get back to grams. My final answer is 12.2 grams of NH3. So step 3 looks just like a normal stoichiometry problem, but I needed to go through these other steps to figure out what to start with.